experience at every touch point? Are you getting your proper recommendations? Similarly, best pricing among competitors. When you try buying, you want to have best price and ideally minimum price. And ideally, every touch has to be getting it's a good product, good quality product, and you are able to get the right product for the right price. Then, in continuing with selection, the informational products that are similar utility, like the chosen item, is it available? For example, when you're making a product, when you're making a selection, let us again take the battery bank, power bank example. When you try buying that, you are trying to look at particular brand, and do we have equivalent brands? So that will help you to make an informed decision about that particular product. Are you getting that kind of information? Do you have access to a large corpus of user reviews before making a purchase? You want to take that product which has positive reviews and possibly rated highest. And there are also FAQs. I mean, ideally, if there are FAQs, how is it working? And if somebody is saying the product was delivered to me within 2 days, it stopped working, you would rather not go for that. So, do you have access to that kind of information? And again, some information from the platform on sale events from time to time. So these are typical, again, customer expectation. Continuing with that, in terms of delivery, there has to be predictability when it says that it will deliver in certain number of days. Is it delivering on time? And is the delivery experience good? The person who comes to deliver to you, is it courteous enough? And if you carefully see, there are certain customer touch points which is like a handshake with the company. It could be the homepage, purchase experience, delivery experience, and the return experience. These have to be, and the call center interaction. These are the things. No? In fact, we don't know any other point within the company where you can interact. These are the places you interact with, and if the experience is good, you are happy. Otherwise, you tend to be that the company is not responding to you. Then that kind of communication you get. So these are expectations by customer will have. Similarly, conveying experiences from multiple channels and channel to share and see with fellow customer experiences. Raise complaints that could be redressed. And do we have an active channel where you can interact with the company? For example, you are trying to search for something, you're not getting it. You want to communicate with the company that why is it happening? Okay. So is there such possibilities are there? These are the things a typical customer would expect for a platform. These are indicative, not exhaustive. It all depends on the kind of platform that you are interacting with, the kind of items that are up for sale. So, but this broadly covers the entire gamut of things. Let us look at organizational expectations. This is a different view, like two sides of the coin kind of thing. Organization typically wants a good customer experience at every customer touchpoint. Once the customer is happy, he would come to the platform again and again and buy it. So he wants to ensure that these things happen. And there is a good conversion. So typically most companies, people maybe out of N people, maybe 0.01% people only really convert. That means they're the only point. So most of the people look at the items, maybe add to cart. They want to compare with other products, equivalent products in the different platforms. Is the price lower somewhere else? And that kind of comparison you do. And at times, it's also like, now I'm free, let me look at, I want to buy in some time, let me look at different products that are up for sale, and I may not ultimately buy. Then why do the people do it? And can we do something from the data science point of view? Is there any model that can help? And a good conversion, as I said, and optimal selection catering to all kinds of customers. So each of us have our own price point. And for different occasions, possibly we'll spend different amount of money. For example, for the daily use, possibly you do not want to spend huge money, whereas an occasional or a festival use, you don't mind spending more money. And also each of us are price sensitive to some extent and are insensitive. So for me, is it catering to my requirements? Is it giving me entire selection that is available? And that's what organization expects. Am I able to cater to all customers? And is it a curated platform where customers are happy to see entire information that you have? For example, you would have seen from platform to platform, the things vary. In certain platforms, when you try to look at that, every information about a particular product is completely available. In some places, they are not available. They are repeat of like sometimes it's like copy paste, cut paste kind of a thing, where the information is not complete or it's like it's not correct information. So they don't want that. From organization point of view, they want to create that kind of experience to the customer. And find revenue generating opportunities like ads in addition to sale and profit that they might make. Are there any opportunities, avenues to generate some money for the company? And again, data hygiene. These are the background models that work in addition to what is provided to the customer. It could be, is the catalog hygiene. For example, imagine a power bank and imagine it is imported from a certain company. You might have seen often that our power bank, or you can see mobile cover. When you try to look for a mobile cover or a laptop stand, you would see exactly same product with different names. Price is also different. Okay, that's a kind of a bad customer experience. Ideally, they should have been collapsed under, say, called vertical, single vertical. You could have seen multiple products there. You don't want to see so many exactly same items with different names there. So, is there exact duplicates in the catalog? Can we minimize that bad experience to the customer? An automatic catalog. When a new seller comes and wants to get onboarded, is he able to get onboarded easily? So that is the other thing. And can data science help in automatic catalog? For example, imagine a case of lipstick. Okay, lipstick broadly comes in the beauty and personal care kind of a catalog. In fact, the catalog hierarchy you can see when you search for a particular product on any platform, any of these platforms, popular platforms we have. You can see that entire hierarchy. It is possible that when it is manually, onboarded, a particular product is onboarded, it is possible that same lipstick may be available under, say, beauty and personal care, or also possibly all the products under face and beauty kind of thing. So these both the things they may be available. That ultimately you don't want to that. Then all these products they may not surface when customer tries to look at and buy. So again, that is what they divide of product duplicates. And good, again, search experience. Again, organization also wants a good search experience. They don't want zero search results. You look for something like, again, I would go to refrigerator, which does not require maintenance for about 5 years. It's a very long sentence. Then easy able to figure out what is there in the customer mind. And figure out that, then it will show that kind of thing. Our most popular refrigerator of 550 liter class. When we do that kind of queries, is it able to show the right products there? And again, prevent platform for exploitation. So there are a lot of fraud keeps happening on this e-commerce. I mean, can we prevent a buyer or a seller making or exploiting the platform in a bank? So they will discuss about little more detail as we progress. But organization expects these type of things to happen. Optimal and apt notifications. Again, you would have got notification, the sale today, have you missed it out? Or something you left in your cart. These kind of messages you may be seeing from different platforms. Sometimes they'll be irritating when they come too frequently. So that's where the optimal notification, apt notification. And every customer has to get the right kind of information. Can it be personalized? Whether the content also, sometimes the messages themselves will be irritating. It's not very respectful. It's like ideally they want to excite you, but it doesn't cater to all kinds of customers. And similarly, shaping customer behavior. How do we engage the customer as he makes the purchase? So, similarly, how do you ensure that he comes back again and again? Then optimal inventory, procurement, where to procure, what to procure, at what instances, how frequently, where do you store, which warehouses you should store across India, how they should be distributed, how they should be moving from one warehouse to another, when they should move, where is the demand, kind of thing. And again, optimal inbound and outbound supply chain is a very loaded word. From the data science point of view, just within this particular area itself, there are as many as 20 different models catering to company benefit of company. Optimal replenishment. When are the items are getting moving out? When is the tipping point? Then this is the point, and we need to immediately replenish. We should go to the buyer and buy them. and store them at appropriate place. Similarly, optimal assortment, what combination of items you should have, like how many battery banks, like you cannot overfill a particular vertical with one kind of thing. So how do you do that? Then again demand predictions in immediate term, medium term, and long term, and optimal delivery. Like I cannot use too many delivery agents to deliver in an apartment complex. Am I sending, supposing every, let us say that number, let us say 10. I mean, it's not 10 is the right number, but 10 is not a right number, but I'm giving an example. Imagine every delivery agent has to deliver 10 products every day. And there are 100 deliveries, but all 100 deliveries are going to an apartment complex. So one delivery agent taking all that, a van taking all that is good enough instead of sending 10 into 10 delivery agents to deliver that. So that kind of a thing, best pricing among the competitors. Are we pricing the items best possible way? And when we price them, are we maximizing the revenue and our margins? So every company tries to maximize its revenue. So that improves the valuation of the company. And it wants to be, sooner or later, they want to be good profitable. Again, personalized recommendations, provide platform for receiving customer feedback through multimedia. Like it will be text that is an awesome product, and I bought a camera. The pictures are excellent, awesome, and this is the photo of the camera. Or I have bought a cot, a queen cot, and I have a bedroom of size 10 by 12, and I would like to share the photo of the cot inside my house. So typically, those things will chime well with the clients, with the customers. So typically, most of us may have the 10 by 12 kind of bedroom, and we want to see whether that kind of a cot will fit into my place well or not. While doing that, it is possible that some images have objectionable content. So we need to filter that. We need to use computer vision algorithm to say that the content is proper. Similarly, text, while they are saying when they are too unhappy, they may use expletives. That we need to see that those things are not there. At the same, and again, video, supposing the company also encourages videos to be uploaded. Again, they have to be cleaned up and see that they are proper videos. Again, mechanisms to analyze and address customer feedback. That was customer feedback. First of all, there should be a platform where there is a handshake. They should be able to get that. The more and more they get the customer feedback, they become more better. For example, you have seen, supposing car hiring, cab hiring companies, you are kind of you are very constrained. You cannot share a feedback. Even if you want to share feedback, it's very, very unfriendly. You have to click so many things to go and give the feedback. Even there, you will have objectives. You have to choose that you are unhappy because of A, B, C, or D. It may be E, maybe F, but you can't say that F there. So instead of that, if you can use free text and inform them, data science can analyze those free text and say concise information for improvement of platform. This is typically organization also would expect what we have there. And again, whatever issues are there, can we redress them? And how can we do that in an automated, fast manner? Let me talk about data science ecosystem. A large sales company. Large is in terms of the catalog, how many items they are selling. Maybe millions of items they are selling. And maybe certain number, again, it's a broad to indicate large and taking million as a number. We'll have at least about 100 solutions that are actively working at any point. So they will be working in the background, foreground, in all the places. And every day, every instance, that kind of problems will be working. Another thing is how these problems come from. Who will define these problems? They can be defined by anybody, and most often they are driven by the business directions. What is that you want? For example, you decide that I want to cater to customers who cannot spend much money. There is a lot of people who do not want to spend huge money. I want to capture that kind of people. Or I want to move to tier 2, tier 3 cities. Okay, this is the business directions you have. And they would say, if I want to go to tier 3 city, what data science can do? How can you help me to generate right recommendations, and what can you do about it? These are all typical broad statements will be broadly like this. They will be very, very kind of ill-defined and very broad sense. Then a data scientist's job is to convert them into formal mathematical statements and solve them for first principles. And most often it happens something like when my first problem in one of the e-commerce companies that I worked earlier is addresses are killing us. Can you do something about it? So you need to figure out what is address, what is killing. You need to go, you need to run the extra mile, maybe physically visit your warehouses, delivery houses, and see what is happening. Then you figure out, okay, this is the problem. Maybe we need to bring some automation there. And then you figure out what should be the pattern, what should be the feature, how do you solve that problem. So most often these are the problems. And sometimes it may be, again, I was talking about conversion sometime earlier. There are a number of come to the platform, they don't buy and move away. What is it we can do about it? So these things are loaded questions. Then we need to see, and we have access to the customer's previous purchases, how is he behaving on the platform. Based on that, can we take informed decisions? And why a customer is not buying? Why is simply browsing and going back? Is it that we are not able to show the right product to them, or the price is higher, or competition is giving at lower price, or their delivery experience is better, returns are handled better? So these are some of the questions a data scientist would look at and tries to analyze the data, then come to the conclusion and go back and explain it. And ideally, the data science team cannot work in isolation. This is one kind of a thing that one should avoid. That's one tendency among data scientists where they try to work in isolation. They want to solve the problem. They are domain experts. They want to see that, give me time and touch me, don't touch me for some time and come with the solution. It doesn't happen that way. You need to interact with business, product, and engineering teams very actively. You need to create those bridges and then understand each other, see their pain points. In fact, no data science model is complete and accurate without including the domain knowledge. The domain knowledge is in the head of that particular operations person or a business person or the engineering. So when you talk to them, only they know that intricacies. They may not talk in the language that you do. For example, when you want to optimize a function, nobody will tell you, okay, maximize revenue subject to that condition or condition to planetary condition. That kind of thing nobody will see. This is something that you need to figure out and form a statement. But they will tell you all the pain points. That you have to internalize them, listen to them actively, ask questions when you don't understand, then think over and come with your own formal mathematical statement. And typical days data science life cycle starts with this vague problem statement. Then try to figure out what you can do about it. Maybe you need to understand the data, play with the data, see what is happening. Then you figure out possibly this is the problem. Maybe I need to solve it in this particular manner. Once you think over in your mind and consolidate that, and it will take some days, sometimes few weeks before you come to this stage. Then you go back to the person who was talking about this problem. It could be business engineering or product people. Go back to them and say that this is what I'm trying to solve, and this is the metric. After solving it, this is what we need to do. Is it good enough? What do you think? So then there has to be alignment. Is it good? Yes, let us go ahead and do it. That's how the journey starts. Then of course, making use of the data, which method, which approach you use it, and how do you solve it? Evaluate offline. Then, if you have to deploy, what is the time available? And it is supposed to be the real-time deployment. It has real-time deployment typically requires your computing time of something like anywhere between 100 to 200 milliseconds, or much lower. Depends on what other engineering deployment happen in tandem. If it has to be shown to the customer, there are sequence of events that happen. Each of that will take its finite time. All time slicing together, is it sufficient to be a real-time solution? If not, again, you have to, even at the time of model building itself, you have to be conscious about that and choose that model which will fit with this kind of computing time. Then importance of first principles approach. So one tendency in data science scientists is like the moment a problem is posed or even ill-defined, you mentally make up that this is the problem that we need to solve. One tendency is to look at what approaches are already there, what is already there in the literature, and can we replicate it here? Most often it may not work. At times it might work, but most often it may not work. You need to take your own approach to solve the problem. Each problem is respected for its complexity and try solving them from first principles. You can use that experience from the literature to solve this particular problem, but ideally one should not replicate some other solution. It might have worked in that context, but that kind of data is not necessary that it will work again every kind of. Now, let me talk about many topics in play in solving the problems. These are the topics that are in play, that are in action as we solve the problem. Natural language processing, computer vision, optimization, statistics, speech models, then graph methods, supervised, unsupervised, semi-supervised learning, synthetic data generation, sometimes wherever that is required. Of course, deep learning has been the lifeline for most of the problems. So these are the things that a data scientist would be conversant with when he's hired and when we look for and then comes the let us look at list of data science problems. Now we have seen what a customer would like on the platform and what the organization wants on the platform, ideally what is that it is expecting, and how data science can help. Here, I'm consciously avoiding talking about engineering role, product role, and business role. I'm only saying there are many ways of solving. For example, when you are talking about homepage personalization, there is engineering angle to personalization, and there is data science angle. I'm confining myself only to data science in this talk. Let us talk about search. Search can happen in multiple ways: by text, image, or voice. Then slowly, it's just a matter of time, and there are already some many platforms that have started, but it's going to penetrate much more. And you would have seen the movement from text to image. So it's just a matter of time. It's going to be by voice. Then the search one should ideally enable all these channels to search for an item. And then again, in terms of the model, when it can be faceted search, then you know that which product, which vertical is there. You can go and search for that particular item in that. It can be a vague text representing a particular thing. Then you need to figure out and try showing that. And the general standard recommendation is when ideally you should view the item that a customer is searching. For example, this is the example we give whenever we talk about a search problem. For example, when you're trying to look at iron table, are you looking for a table made of iron legs or a table for ironing your clothes? And similarly, again, baby diaper example. Those kind of things, like each that what is that one has to show, he has to understand what is that he wants to show. And I will take this baby diaper a little later for replenishment models. For example, imagine you have a small baby of say 2 months old, and a person bought 50 pack. And can we recommend that now the 50 pack, say it will come for a week, 15 days or a month? Can we recommend a week earlier that possibly your pack is over? Is it time to buy maybe next size or the same size, bigger pack, same pack? Can you give some discount? So that kind of recommendations. That is what I was talking about. Then personalized search. So now I'm talking about frequently bought items. So let us say it's like a vegetable and normal food kind of a vendor. And usually I buy certain bread brand. And when I search for that, essentially when I type bread, is it showing the brand usually I buy? So that kind of personalization is it happening. So also it can be applicable to anything, right? Because I need to restrict it to these kind of frequently bought items. I'm doing it. Otherwise, it's supposing that something is not frequently bought, supposing definitely of say 500 liter class. Then what is popular? What is popular? What is frequently bought by different customers? Possibly that is what is shown. Then personalized recommendations at various touch points. Selection. When you select a particular item, are the equivalent items shown here. And equivalent again is a loaded word. When you look for similar items, the similarity can be price point, or in case of battery, power bank, the capacity, or the color that you are choosing, or longevity, or rating. So each of them can be loaded. So that decision where that similarity has to come from has to be a joint decision between business, product, and data science. And similarly, selection of items, similar items, equivalent items are shown or not. And at the time of that, can we show, supposing I always buy brand A, can I also be shown brand B of similar quality, similar price, similar color? Then only I would go. Otherwise, I would always stick to the same brand. And from the company point of view, the organization point of view, I'll be left with other brands which I bought because that particular brand is getting sold. How do I nudge the user to look at different equivalent products? Again, when you add to cart, can there be recommendation that you are adding this? I mean, do you also want to buy this? Like they're called, also called bundles of products that are bought together, virtual bundles kind of thing. Then at the time of purchase, can there be recommendation? And end of the purchase, for example, you have bought items at a certain price. Possibly, if you buy somewhere, supposing it costs around say 3,900, at 4,000 you have an offer. Then can I suggest, for example, you have bought shoes, belt, and something like that. Can I recommend some socks so that you will cross that number? See, ultimately, two things. No, first of all, I want to increase my revenue. I want to sell as much as possible. That's one thing. Second thing is something is helpful to the customer. He might have forgotten. It's a natural thing that I buy. That you buy and you buy a shoe. And the socks, you are not very restrictive. You don't really think that okay, per week I use 5 socks. Let me buy 5 socks. You will have much more, many more pains. So that kind of recommendation. Okay. Then in case of fashion, can I virtually try on? For example, I am wearing, I'm seeing a shirt with checkered shirt. Can I, without wearing that, how does it look on? And in such a way that it takes care of my body shape. So you see, I don't want to look like a very like a six-pack person. That it's not like I'm not like a model. I am what I am. So I want to see a particular shirt on my body, in my body shape. Can it be done? That's a great customer experience. Then he can decide, yes, this will look out good or not good. Depends on how checkered, how size, how close are we. Will it look good me or good on me? That kind of solution. Again, chatbots for interaction. It's not just FAQs. It has to be, it's a proper interaction. For example, I am going for a beauty product. I'm female. And I'm trying to ask that I'm going to buy this foundation. Will it good on my skin color? So one possibility is you can ask them to upload your picture, then analyze your skin and say that yes, for your skin, this is the right foundation, please go ahead. Or that's not the one, you must use this. Otherwise, it can say for different skin types, these are the foundations that you should use. So these kind of interaction with meaningful response. Understanding that, at the same time, understanding the content from the beauty products. So when they have pages of information on each product, can we summarize? How do you generate the so-called question and answering kind of thing in it? So those kind of things, how do you prepare yourself for that? So again, this gets into NLP and natural language understanding, natural language generation. These are the important concepts when we talk about chatbots. Again, product deduplication. Deduplication, again, that's a cleanup of your own catalog. What otherwise may have, maybe supposing it may have 10%, 20%, and 30% kind of hygiene duplicates. That's unnecessary. It's not required. Sometimes you may have to revamp what is there in your catalog. So as I said earlier, lipstick example, I was saying, it may be available in 2 different verticals. Can we collapse them? Can we properly place them on that single vertical? And so that I can have a clean information. Another thing is there can be each product will come with certain information, description about a product, and keywords about a product, and also image about the product. So those things, are they available? Are they complete? If they are incomplete, how can we make them complete? Ideally, when our product is getting onboarded, these things are taken care of, but they might have missed. and you might have ended up with a lot of products with incomplete information. Data science can help solving the problems by looking at different products, either by taking public domain information or the product information. Then again, attribute extraction from image and text. Imagine a product is given, it could be a refrigerator, but can I create a description of the refrigerator by color or the capacity, dimensions, kind of thing, or a t-shirt. Can I generate description in the short sleeves, round neck, with the graphic print, that kind of thing. Can I generate that? Can I extract those information? And also can I create a description about that? Again, I talked about automatic onboarding of products and that. And product similarity in terms of attributes, that means textual attributes, as well as images. The similarity.
Yeah, you can go ahead.
Extremely sorry for the inconvenience. There is some small technical glitch. And yes, we were here. And the other thing is like content moderation in terms of text quality. When a product is onboarded, ideally some text is uploaded here. Is it complete? And if it's not complete, then the data science models can help there. In fact, there are a lot of data models can be built there to make the information complete by learning from similar products in both in public domain and the private domain. What is the data that is available? And also some attributes, the missing attributes can be completed so that the information is complete and they become searchable when you try searching for that particular product. Those keywords will help searching for that particular product. And the choice of text that is used to describe product, image quality. So it is possible that the sellers can come from different places. And supposing you are trying to sell a mobile cover, the seller is from a tier 2 or tier 3 city town. And it is possible that when he tries to upload an image, the quality is not good. And he may not have access to a high resolution studio kind of a setup. Then in the given image, computer vision can help you to create through image super resolution. You can get into a better quality of things. And similarly, product vertical revamp, I talked about it. How can we clean it up and create proper, meaningful verticals? Then text summarization in case of books. Supposing you are selling books, and on the back page there is information about the book, and that runs into one or two A4 sheets. Can we summarize into a small text so that you will know better? So these are the other data science models that could be used. Advertisement itself is a huge area. How can we guarantee that certain advertisements are shown? And can we guarantee the people who wants to advertise that it will be visible? And how can we create those guarantees? And ultimately, it will turn into revenue earning opportunity for the company. Again, moderation of user-generated content. We talked briefly earlier, the text, images, video. When there is content is generated, data science can help build models, both in terms of NLP and computer vision to solve those problems, to identify that things that are with bad text or bad images. And you can prevent going onto the platform. And at the same time, the company should be mature enough to post even the critical comments that is goes a long way on the in building the trust or the platform. And the other thing is about like reviews and ratings. Again, moderation, there is a fraud angle to that. It is possible that when you have competing products, you are selling certain products, there are competitors. It is possible that some sellers may jack up their ratings, artificially raise the ratings of their product and pull down the ratings of the competing product. So data science can help in identifying that kind of malpractice. And optimal pricing models. How do you price different items that are there on the platform, such a way that you maximize the revenue at the same time margins are maintained. And there can be so many other constraints which can be met when you try to do algorithmically. Otherwise, it is a domain of a certain group of people who have the target of meeting the revenue and profit. They have their own ways of doing that in pricing the different items. But algorithmic pricing will go a long way in terms of solving this problem in a systematic and mathematically sound way. Again, optimal push notification we discussed briefly earlier. Again, with NLP-based models and combined with optimization, we can decide the timing and number of things. And we also analyze how many, when we send number of notifications, how many people really acted. So should we moderate them in terms of the number of notifications that would go and the content they would go. And if there is a feedback channel that is open and company is getting the feedback, can analyze and bring that feedback into the modeling. Similarly, we talked about replenishment. One example I gave is about baby diapers, where how they should be replenished. It could be anything, any consumable items, maybe toothpaste, maybe vegetables. So you know that have to be bought at certain frequency. How can we really do that kind of thing? And also identifying, inform the organization that certain models are getting over, you need to buy them early, and it takes, you have the lead time, before once you order, it will take its own time to come back to the warehouse. Then considering those things, we need to build models and inform things. This is again typically it belongs to the statistical prediction and optimization kind of work. Similarly, optimal allocation to warehouse. Which warehouse, what should contain? What is the demand in that region? For example, imagine Diwali. Diwali is popular across the country. And any items that are specific to company, that particular festival, they should go, irrespective of the place, you should go to across all the warehouses. Consider Onam at Sankranti. In certain places, it is celebrated in a particular way. Those kind of items, it is sufficient to store in those local things. For example, Kites Festival. It's more celebrated in, say, Gujarat and maybe Hyderabad in some places. So those places, those kind of products can be there. It could be less number of products in other regions. These decisions are made by data science models. And regional demand forecasting, optimal assortment. We talked briefly about these things earlier. And again, as I said, optimal allocation to warehouses. Just now we have talked about Kite example and Sankranti, Onam kind of example. And regional demand forecasting of each item, every item that we have, what is the regional demand for that? And can we, that will go a long way. Then how much to store, how much you have to move in advance to a particular place. And again, warehouse store optimization. Where do you place items? What are the items that frequently go? What are the items that are rarely bought? Where they should go? Imagine there are what we call them as pickers, the people who try to pick the items. And those pickers, how quickly they have to go to those ways and they can come back and bring that. So naturally, the frequently bought items, if they are put together in a common place, they can pick those things and quickly come back and place them in a place. Then optimization of the pickup area, number of pickers, the staging area. They will take it and put it in the staging area. From there, it will go to packaging. There will be 2 stages. So even any delay in any of the stages will delay them. Then again, data science based on queuing, theory and other models, we can solve this problem. Optimal packaging. In a company, you might have seen, for example, you are ordering for shelling cartridges that are over, and you want to buy 2 cartridges or 5 cartridges. And you might have seen places where there is a large pack containing a small cartridge will come. So how do you decide that? If you leave it to the packer who is doing the end job before it goes to transportation, whatever packing that is available, he will also not like to use a huge packet, but quickly whatever is available, he will take it and pack it and leave it. Instead, imagine a data science model works in the background. First of all, you have to analyze how many packages, what sizes are there in the company, how many optimal packages, maybe 6 levels of packages is good enough. So, or 10. And can you recommend certain packet for a particular thing? Or next level, can you automatically push out that particular packet to the packer? Then he can take it and just pack it and just go to the next level, paste the address. And there are places in major companies where robots do this kind of movement of thing, taking it to the next level. So even there, replacement matters. Ultimately, where do you place? How do you that kind of will improve the time? Then, in terms of again outbound, like as I said earlier, in inbound outbound itself, we have easily anything like 20 to 30 models that work. Address models for addresses without geolocation. Still, India is a vast country. Not every address has geolocation. And in tier 2, tier 3, all the more difficult. So can we then you have to depend only on text to build models. And again, there are wherever these maps are available, can we use map-based, geocode-based models? And optimal shipment assignments to delivery agents. Again, not all delivery agents are equally efficient. And then we need to allocate appropriately and maybe also use some incentive mechanism to make them do better and also identify right items to right people. And there is also fraud angle to delivery agents. Are we monitoring? Are there any complaints with the particular delivery agents? We need to monitor and try remedy that. Shipment non-deliverable. it is possible that some address when it is mentioned, it's incomplete, it's not deliverable. When you realize that at the time of delivery, it's too much, no? Like for example, the entire ordering system got activated, it is picked back, it has gone to delivery hub, just before delivery, you realize that it is not deliverable. Can you do it upfront? The moment it is getting ordered, you say that sorry, you build a model, the model is done, it says this address is not deliverable. Then you will go back to the customer, your address is not deliverable, please re-enter your address, or we will not take the order. There's a lot of money is saved in this process. Likewise, there are many places in data science models can be activated and bring goodness to the company. Optimal stock movement, how much to move, what to store where, how many trucks you have to use, what kind of different mechanisms you can transfer the thing. Is it possible that in advance you store this thing and so that they can be picked faster and they can be delivered? Again, when the truck really arrives, it is arriving on Sunday where not many people are there. It's not even downloaded and it's not really put back in the warehouse. So all these constraints, all these models, promise models, they take into all these constraints. Again, the same thing is promise time prediction. So ultimately, customer is happy if it is delivered faster. Supposing, imagine you have a Wi-Fi router and you suddenly notice there is an important meeting tomorrow. Your Wi-Fi router strength is not good. You want urgently to buy one. So you go to your popular site and want to buy, and somebody who delivers in 2 hours, you would love to have that. And that kind of thing. At the same time, just to see the opposite. And your sister's birthday, you want to buy a gift to your sister. And you want it to be delivered on the birthday, not a couple of days earlier. You want to surprise your sister. And can any platform ensure that? Not many do that, but that kind of thing. How do you do? But these kind of things, these models take into account both the operational difficulties and the business requirements, actually on ground what is happening. All these things it can take into account and predict that with these conditions, current conditions, this is the promise we can give to the customer. Based on that, we give the promise time. So this again, there is a game. No? For example, there are certain constraints in operations team. They don't want to breach a promise time. So if you don't want to breach, you have to give longer hours. Maybe what could be possibly delivered in a day or two, you would like to give 2 because you don't want to say 1, and if you breach, say bad remark on the team. You might give 2. That the moment see 2, maybe customers get repulsed. They don't want to buy that because 2 days is too much for this particular item. So there has to be trade-off. So data science will help to build that model and give that promise. Again, call center approach. Call center executive performance evaluation. How many calls are they attending? Are they doing it properly? That kind of performance evaluation. And NLP solutions that speed up responses. So if you analyze how many calls a call center is getting, what is the category, what broad cluster of problems that typically they have to address, and can you create a priori responses to those queries? And the moment call center gets that answer, by click of a button, he gets that response. This is what you have to respond. Then he responds, customer is happy. As I said earlier, these are the face of the company to the customers. If they respond well, customers are happy with the company, they will come back again. When they don't respond well, it's unfortunate. They will be unhappy that when they have a problem, it never gets redressed. Similarly, nowadays, you would have seen that when you try to reach out to them, when they are not available, they said, we'll call you back. It happens. That's a to ensure that good customer. Similarly, voice-based sentiment analysis. Is somebody shouting at these customers? Can we analyze based on voice? Not necessarily the words they use, of course, including words they use, but the pitch they use in terms of, again, here voice and text-based solutions on that. Fraud modeling. Again, that itself is a huge area that, in fact, company bleeds on this. Ratings to reduce fraud. As I said, I gave an example of somebody artificially improving their own rating and putting out somebody's data science models can graph these models have worked, and there are a lot of publications available in the area. Again, buyer fraud. When you want to, giving large discounts on certain products, and you don't want, see, when say 1 lakh mobiles up for sale, A company wants to have 1 lakh happy customers. The intention is not to sell 1 lakh mobiles, but 1 lakh happy customers. How do you ensure that each mobile reaches only one person? Then you have to add restrictions. When you add restrictions, we are smart. As a buyer, supposing they call it a buyer has its own way of selling it again. So those buyers, you have to prevent them to order more number of items. When you put constraints, the buyer is more intelligent and he would come out with another loophole and he tries to play with the system. So it's like a cat and mouse game. It's like virus, antivirus kind of. So then how do you build models, continuously update the models to ensure that it's fraud is. Similarly, seller fraud. When you sell an item, it is possible that supposing you sold shoes, say sports shoes, white sports shoes. Ideally, any normal customer would try it out and it doesn't fit to him, then he would immediately return that item because he would go for next size and one size higher or lower. But there are customers who would use it for a couple of days and they're not happy in their site. By the time it becomes dirty, it's not sellable to anybody else. So then the company has to kind of a notional compensation they might give to the seller. But is seller exploiting that in a bad way? And is he saying even if it is not dirty, he says it's dirty, not sellable, give compensation. There again, we can build data science, can build models to look at that. Similarly, pricing fraud. Imagine there is a shoe that is costing around 4,000 rupees. Now I say that I show the 8,000 rupees on the platform and say that it is 50% discount, 60% discount, and that is still higher than what is printed as a market. It's a bad customer experience. Then how do people play with the pricing and those type of fraud? One such fraud. There are many such frauds. For example, an imported item versus a Indian-made item. They might show it as an imported item and they jack the price higher up. Exactly same, for example, a particular soap that is imported as well as currently locally available. So those type of things. Delivery fraud. So you would have heard in the newspaper and news articles, news items like I ordered for certain thing, instead I got something else in the packet. And the packet looks like tampered. And the organizations continuously innovate to minimize this kind of things. They have a lot of mechanisms. You would have seen OTPs nowadays, they ask in the time of delivery. And tamper-proof packaging. And so many things. Monitoring the delivery and server delivery. All these things kind of thing they take into account. So here again, data science helps to build models and analyze the behavior. Similarly, there are many models that tries to understand customer behavior and hidden patterns. It could be massive user graphs. Imagine you have 1 million customers, there can be massive user graph. And patterns, you can detect, you can mine for similar patterns among these huge graphs. Then address clustering. Similar addresses that are clustered, then it can also be to prevent fraud hacking. And also to know addresses of similar natures, how many are there in a given region. It will help in supply chain to do better. Geo clusters of customers, regionalized clusters. Mining of hidden patterns. One is whatever is there visible to you, that the hidden in that. In massive data set, there are hidden patterns. There are many algorithms can be run to identify those hidden patterns. Virtual bundles, creating that people who also buy these items. Can we declare that? Once you do that, you can make recommendations. And there are multiple applications. The ones that are available, you can help in a warehouse, can be helping packaging, grouping the items for sales. In sale events, you can bundle them together as a sale event because we know that they sell together. So I can promote a new item that was not getting sold by bundling them with other items. So likewise, there are multiple applications. Then is the customer lifetime value. Each customer, if I know this one, accordingly I can make a lot of business decisions for tailor-made for a customer. And these are all the models that work in the background, just in a passive manner. You keep looking at the customers, what more insights you get the customer, so that these things, those signals will become part of the other models that work for the car. So broadly, I have given overview of all the models that work in a particular e-commerce company. They are all there are many more models. In fact, even the companies that I work, there are many more models. I did not, wherever these models are in public domain, and there are publications, I mentioned them. And wherever not, they are not coming public, I avoided talking about them. But each company will have its own requirements. Their business directions may be different. What they want to maximize may be different. Accordingly, data science has to understand those, data science teams have to understand those requirements and accordingly cater to those requirements. And understand the organization expectations, customer expectations, meet both of them. And solutions that are customer facing as well as work in the background, we're all required to work in tandem continuously. Now, I have given ecosystem wise, I talked about vague business problems, base life cycle we discussed. And most often we get vague business problems. Then we need to figure out a formal statement and solve the problems. And it is very important to collaborate with stakeholders. We cannot work in isolation. And I have not discussed the entire the massive area of deployments, the latencies, and how do you deploy, how do you monitor, how do you create pipelines of petabytes of data catering to model building. And if it is in real time, there are many more challenges. Offline also, you have a lot of challenges. So those aspects I have not covered, but there are many nuances towards that. Again, monitoring of drift and retaining cycles. Again, like a model drift, data drift, then you will have to retrain the algorithms. And retraining cycles, depending on the model, will be different. Sometimes it will be online learning, then and there you have to learn. Sometimes it's weekly retraining, daily retraining, monthly retraining. Sometimes the 6 months you don't have to retrain. It all depends on the problem, the kind of data change that may occur, what kind of variation they have. And operational issues have to be taken into account when we solve the problems. And similarly, monitoring data science performance when they get into problems, how do you really alert the data scientists to look at the problems and find remediation? So these are some of the publications, and all these publications give a foot into that area, and there are different areas, different topics, and more or less discover the topics that I do. Last 11 publications I contributed. I worked as my first other publications are I worked along with the team. So these are broadly the areas and publications. Thank you. I'm open to questions if you have any.
Have a conversation on so a few slides back, there are some mention of synthetic data analysis. That is, if my understanding is correct, that's the pain. Where is the application of
that? Sometimes when we try to, the question is the need for synthetic data generation. So it's not, when we try to solve a particular problem, it's not necessary that you always had enough, say, positive or negative labels. And when we do that, for example, a product scenario kind of thing, when we do that, we may need to artificially generate some examples. So that is where you require to generate larger data set, so that the model can be built and assessed. That's where you require.
Is there anything which includes like end-to-end on this one? I mean, data like mass production you have into public. Like, is there any like end-to-end?
Very less. That is the idea actually. The very idea of doing this DevDay talk, instead of talking one topic and go deeper in that, The very idea is to give that overview. Normally, I don't think there is any book that covers everything. This is a practitioner's skill. So, because you work in that area, you know that this is the entire view, this is 60-degree view of the problems. I don't think there is one, like for each of them, as I shown, no, in terms of references, those areas you pick up. But a bird's eye view of how a customer would work, how a e-commerce company would work, and what kind of problems would be there. I don't think there's information for people. There's nothing like a survey paper there, to my knowledge.
Okay. Is it in future term? It can be in current or like it can be like open.
See, each problem, each company requires a different type of things. So that way, I mean, there's no need to keep as a entire. I mean, you need to bring out a book which will cover everything. Kind of thing. Maybe somebody would take the initiative and think that. Yeah, I don't think there is a survey paper. Definitely, there is a need for that. It's good to sensitize everybody. That is the idea I have picked up this topic. Although I have carefully avoided all images, pictures it are much better. Then I have to use somebody's picture. So then again, I don't know whether I have permissions or not. So that's where I avoided pictures. It's required. I agree with you. It's required that somebody has to give that comprehensively. A practitioner only will give you that kind of thing. For example, somebody is working in recommender systems, he knows deeply into that area, and he has multiple publications in that area. Similarly, somebody is working in demand prediction, he would understand, he would have had publication. But tagging all that, entire customer journey, at every touch point, what models are there, I don't think there will be any comprehensive survey. There can be, like, for example, there are attacks, no? Like normally data science also can solve the problems. Usually there are, it's okay. The question is about are there any data science models for say login attacks or kind of a thing. So data science can solve the problems, but engineering side, there are ways of preventing that. There can be checks and balances while doing that. For example, there is a brute force attack with an OTP or something. You can always prevent. You can quickly identify those IP addresses where these are emanating. You can stop them. In many cases, they are good enough. Otherwise, in a conventional data science side, we can look at a different how much of data packets that are coming in, how much are going out, what kind of attack is there, how much time how many times, what is the frequency of attack. So likewise, you can think of at least 50, 60 signals, and you can build a ML model. There are solutions to do that. You can build an ML model and prevent it as soon as that is done. And they are very, very fast. They are not very difficult. You can build that. But again, like I said earlier, like a fraud thing, like they keep evolving. There will be newer signals, newer way of attacking will be there. So you need to be conscious and you need to frequently do the model. There are models. I had worked in that area, but not within the e-commerce companies. Outside e-commerce companies, I had worked on that. It is possible, but there are preventive mechanisms in a conventional operation side and side, which will work for you.
I think there are some companies which use ML rather than this way. Google is one example. So when you log in from any device, sometimes it asks you for your OTP or a second device, sometimes it doesn't. So they have an ML model running in the background that you kind of answer to your IP address, where you're logging from, what kind of device, and your previous history. You usually log in from different devices all the time. Based on that, they sometimes decide whether you want to get an additional offer.
No, nothing yet.
So, like it's a blockchain. I mean, like the security blockchain. Is it like to connect the data? Is it like data?
At least I haven't so far. I haven't seen any applications there.
Because like they are like mentioning that Web3 is like AI and blockchain. It's like
At least not to my experience. I have not seen. The question is about synergy between blockchain and data science models. At least in my experience so far, I haven't seen in the. But definitely that's an area one should look into. Yeah, yeah.
We talked about avoiding patterns or the existing patterns to be followed. It's first principle of one that instead of using some existing pattern, come up with some new what is that? It can't be.
Okay. Yeah. The question is about why should we follow first principles approach? Why can't we use a solution that already worked elsewhere? Why can't we replicate? That is a question. So typically, when we work on data science model, they would have used a particular data set. I'm not saying that it would never work, but blind replication is dangerous. So it would have worked for that particular data set, which may be distinct from the currently whatever you are using. The signals may be different. The importance of one particular feature may be different from what is happening elsewhere. So that's where blind replication is dangerous. But you can still take the approach they have used. Approach can be repeated, but not the blind replication. That is dangerous. Those workflow you can still use. So maybe they have used the CNN, then after that they would have done something. Those kind of things you can always follow, but not exactly blind replication of that code and that text.
There is a question on chat. So the question is, how important is domain knowledge for a data scientist, or can one learn on the job? If it is a prerequisite, how can one develop it?
Yeah, I hope all of you must have heard the question. So domain knowledge is important. When we try solving the problem, you need to understand. I'll tell you one example. Supposing promise time prediction. And the promise time prediction, you really, when you talk to the operations team, you understand the problems. That the stock doesn't come on time, lorries don't come on the time, and when the 2-3 trucks come from say Chennai to Delhi, imagine, and they bring a lot of material to Delhi. It's almost, and all of them land on the same day. It is impossible to pick the items and try delivering it the same day. You need to, first of all, you bring them, try to understand, scan all the items that have come from there, then try to segregate them. It would take 2-3 days. So that also will delay things. These things also have to be integrated into model. Possibly you can also recommend that what can be done. So domain knowledge can be understood. That by keeping your ears and eyes open, by talking to the interaction, that stakeholder team, you will understand these kind of nuances. And you cannot get entire domain knowledge much before getting into them. When you get into the water, you know the depth. So that's how you can learn. We don't have to learn a priori. So what you can learn in a university training is the approaches, methods, metrics. For example, when you build a model, how do you say that the model is working well? What is the accuracy? And what accuracy metrics you have to use? Is there imbalance in the data? If that imbalance is there is, for example, fraud. There are far many good cases than bad cases. So in that case, what should be the ideal metrics? So this is what you come trained to the work as a fresher from the university. As an experienced person, you would have solved certain problems in certain domains. Now, with that experience, you start solving some new problems. So very rarely you will have entire exposure to the problem before you come and start working in this unseen in the new company.
If there are no questions, we can probably wrap it up.
Thank you so much. Thanks, and thanks, Chennai Sahaj team for giving this opportunity. So my intention is to give an overview of what happens in e-commerce a complete 360-degree view of how the problems come, how do you solve, how different points of view have to be put together, how data science can proactively get in and try solving those problems, and why collaboration is important, why you need to understand domain well as you solve problems, why you should not replicate unseen problems, why you should stay intact with the first principles approach. You understand the domain, you try to figure out how to solve problems. So this is the idea is to give entire picture for the even the experienced people and the freshers who wants to understand what is happening. Thank you for the opportunity. Thank you for coming, all of you, to come to the office and attending. Thank you.
Thank you.